Inventions That Changed the World by David Mall. Penguin Readers, Level 4. Text copyright David Mall 2005.
Chapter 5. Engines. Until about 300 years ago, power came from the wind, from water, or from the strength of humans and animals. Using these forms of power, machines were built and people sailed around the world. But the invention of the steam engine was the real start of the modern age. The steam engine. In the 1st century, the inventor Hero of Alexandria described a ball with 2 jets. When the ball was filled with steam, the jets made it turn round and round. A model of this was made quite recently. It turned 1,500 times a minute. The problem, though, is that this kind of machine only works well at high speed. Hero liked to make mechanical toys to entertain people, and it is possible that he used this machine to power some of these. It is unlikely that it had any other uses. A number of other writers in later centuries suggested ideas for better steam engines, but it took some time before anyone made one that actually worked. In 1690, the Frenchman Denis Papin wrote a description of a steam engine. He then actually built one, and it was used to lift water up to a higher level. In Papin's engine, water inside a tube was heated until it turned into steam and pushed up a round metal plate. When this reached its highest point, cold water hit the outside of the tube. This turned the steam inside back into water. Water takes less space than steam, and the fall in pressure with the pressure of the outside air pulled the metal plate down again. In 1698, the English engineer Thomas Savery built a steam engine that used 2 metal containers. Steam was put into each of these in turn. When cold water hit the container from the outside, the steam turned into water again, and the change in pressure could be used to lift up more water. Savery's engine, though, could only lift water a few meters without using pressures which might cause an explosion. In England in 1712, Thomas Newcomen, independently of Papin, had drawn plans for a steam engine. In his engine, the steam was heated separately before it was introduced into the tube at low pressure. The round metal plate was connected to a long piece of wood, and the other end of the piece of wood lifted water. The weight of the other end made the metal plate go up. When the water turned into steam, the fall in pressure pulled it down again. Since the tubes in Newcomen's engine, as in Papin's, had to be heated and cooled repeatedly, it could only operate 12 times a minute. Like other engines before it, it was only useful for lifting water. It was widely used by 1725, though, and continued to be used for 60 years, in Britain and in a number of other countries. James Watt. In Glasgow in 1763, the 28-year-old instrument maker James Watt was given a model of a Newcomen steam engine to repair. This model was used by the University of Glasgow for teaching. While he was working on it, he thought about ways to improve it. The idea came to him on a Sunday afternoon in 1765, during a walk in the local park. He realized that if the steam was turned back into water in a separate tube, the main tube could be kept hot. This greatly increased the speed of the engine. At the same time, it reduced problems caused by repeatedly heating and cooling the tube. Watt's new engine was 4 times more powerful than Newcomen's. Until 1774, cannon were made with a hole down the middle, which meant that there might be some weaknesses in the barrel. In that year, the Englishman John Wilkinson invented a machine for cutting out the center of a cannon. James Watt had been very worried about the escape of steam from his tubes because they didn't fit round the metal plates tightly enough. The 2 men started working together, and Wilkinson's new machine was used in the production of Watt's engines. Within a few years, Watt had built an engine that introduced steam both above and below the metal plate, allowing a double action. He continued to try different ideas, and in 1781 he produced a new engine. Unlike his earlier engines, where the movement was up and down, this one could be used to make wheels turn. Until that time, factories had to use horses or water power to make their machines work. Now, one of Watt's engines could do the job, and do it better. It was soon used in many factories. Although he was responsible for moving ideas forward in a number of ways, Watt can also be blamed for slowing progress down. In 1755, he had been given the right to stop anyone else making a steam engine like his. For the next 25 years, his company made almost all steam engines, and Watt charged his customers a lot of money for using one of them. He compared his machine to a horse, which, he said, could pull a weight of 82 kilograms. So a machine might be, for example, a 20-horsepower engine. Watt worked out how much money each company saved by using his machine instead of a team of horses. The company then had to pay him 1/3 of this amount every year for the next 25 years. When James Watt died in 1819, he was a very rich man. High-pressure steam. All of Watt's engines used low-pressure steam. He always refused to make high-pressure engines because he was afraid of explosions. The move into high-pressure steam was made at about the same time by two men, Richard Trevithick in England and Oliver Evans in the US. Evans had begun to work on his high-pressure steam engine in 1773 at the age of 18. In 1789, he invented the first steam-powered land vehicle. It is possible that Trevithick borrowed his ideas from Evans, but Evans never said so, and it is more likely that he had the same ideas independently. Trevithick came from Cornwall, in the southwest of England, and his most successful engine was called the Cornish engine. He was also the first man to build a working railroad engine in 1804. This could move at 6 kilometers an hour. His example was followed by George Stephenson, who built one in 1815. 10 years later, Stephenson's engines ran at a record speed of 25 kilometers an hour between Stockton and Darlington in the north of England. This was the first railroad to carry passengers on regular schedules. Stephenson's engine, the Rocket, pulled 21 passenger cars containing 450 passengers. Steam was used to power boats and ships from the very early days. The first steamboat traveled up the River Saône in France in 1783. By the end of the 19th century, the world depended on steamships for moving things from country to country and for defense. Although a number of steam-powered road vehicles had been built during the 19th century, their great weight had meant that they were mainly limited to farm work. At the end of the 19th century, although steam was used to power trains, ships, and factories, local travel still depended on the horse. In fact, the number of horses in London at the time had become a great problem. Hundreds of men worked to clean the streets that they passed through. Gasoline and jet engines. Human progress needed a new idea, and it appeared as the gasoline engine. In a steam engine, a fire heated water to produce power. In this new engine, the gasoline itself was lit inside the tube. The French engineer Alphonse Beau de Rochas first had the idea in 1862. In Germany, Nikolaus Otto turned the idea into a working engine. Otto sold around 35,000 of his engines in the next 10 years, and by that time, other German engineers had built better ones. Gottlieb Daimler had worked in Otto's factory from the early 1870s and had helped him with his new engine. In 1882, he left and started his own company with Wilhelm Maybach, and in 3 years, they built a modern, lightweight gasoline engine. In 1885, Daimler produced the first motorcycle to test it, but Carl Benz had built a gasoline-driven car by the same year. Daimler and Maybach showed their car a year later. In 1892, Rudolf Diesel invented a different kind of engine. This used a heavier kind of oil which lit under pressure. His idea was especially useful for heavy ship or factory engines. Frank Whittle joined the British Air Force at the age of 16. He became a fighter pilot, a test pilot, and then spent 1934 to 37 at Cambridge University studying mechanical sciences. He realized the need for a very fast airplane which could use the thinner air higher in the sky. By 1930, he had invented a jet engine. Like the gasoline engine, this burned gasoline and air, but instead of using the power to make a propeller turn, it sent the hot gas straight out behind the airplane to push it forward. The government didn't seem interested in his idea, so Whittle started a company, Power Jets Limited, in 1936. The first engine was ready for testing the following year. The beginning of the Second World War changed the government's attitude, and Whittle's first jet airplane, the Gloucester E-28-39, flew in May 1941. It reached a top speed of 600 kilometers an hour and a height of 7,500 meters. In Germany, Hans Joachim Pabst von Ohain had built a jet engine in 1935, but he received more government support and had his first jet, the Heinkel HE-178, in the skies earlier than the British machine. On the 19th of July, 1942, the Messerschmitt 262 took off. This was the world's first jet-powered fighter. The first British jet was used by the British Air Force in 1944. Progress was slower in Germany because of engine problems with the Messerschmitt 262. In the end, around 1,430 airplanes were built, and they appeared in the skies over Germany in the final months of the war. They were very fast, but could only fly for a short time, and they made no difference to the result of the war. But the new knowledge in both countries was useful in the following years. Since then, jet engines have been used to fly people around the world in greater and greater numbers.
End of CD 1.